What's up, all you badass mathematicians? So today, we're going to be taking the derivative of x squared using the limit definition. So let's start out by graphing our function. Alright, so what we're going to be talking about the slope of this tangent line at any given point x. We're going to try and find this algebraically. And as a reminder, the definition of the derivative for a function f of x is the limit as h approaches 0 of f of x plus h minus f of x, all divided by the x values, x plus h minus x, which is h. So we're trying to find 2 points nearby each other and taking their average rate of change. And by shrinking the distance in x values between the 2 points, this value right here is h. By making this interval smaller and smaller, we're able to get closer and closer to our instantaneous rate of change, which is our derivative. And so when we run that limit as h approaches 0, we'll get exactly our instantaneous rate of change. So now if we want to apply this, the limit as h approaches 0 of f of x plus h, in this case our function is x squared, our input is x plus h, so x plus h all squared, minus f of x minus x squared, all divided by h. Now this is going to be equal to the limit as h approaches 0. A quick side note, a common mistake I tend to see is people stop writing the limit. So if you forget to write the limit here and you continue on, and you're actually violating this equality right here. So it's always good to double check that when you're doing your work, your math is actually correct. So continuing on, we have the limit as h approaches 0 of x squared plus 2xh plus h squared minus x squared all over h. And next we see these x squareds will cancel through subtraction. So this is equal to the limit as h approaches 0 of 2x plus h times h. So now what I did here is I factored out the common h. So and a good practice when factoring is to always multiply it back through. So now I multiply an h by 2x, I get the original 2xh, and I multiply h by h, so I get the original h squared. And so the reason for factoring here is now this h in the numerator and this h in the denominator will cancel out. So by using this algebra, we were actually able to make it easier to solve our limit. Because remember, if we were to evaluate our limit directly at the start, meaning just plug in 0 for h, we would get a divide by 0 error. And dividing by 0 is undefined. So to be able to evaluate our limit directly and plug in h, we need to get it into a well-defined form. And we can do that by using our factoring skills. So now we can evaluate the limit directly, equal to 2x plus 0, and that's equal to 2x. Now note, I could drop the limit as x approaches 0 here because I'm actually evaluating the limit. So I'm plugging in for h. And so now we get our value for 2x. And now we should ask ourselves, does this seem reasonable? If a positive value of x, I'll get a positive slope. And that seems to be the case here. And if I get a negative x, I'm going to have a negative slope. So little sanity checks like this will save you a lot of trouble in terms of simple mistakes. So I hope that was helpful.